Good day. My name is Dender Tumalay from BS Packaging Engineering, and this is my lesson about area using integration. So let's start. Um, Area using integration. So first, let's have a an example here. So let me adjust my volume first. Okay. So let's have here. Let's create a function here. So let's say the limit of a function is at a and b. So having a and b, say this goes up here and like that. So the slope we can call y equals f of x. So we can't really um, tell what its volume is. Reason being, it is not a simple shape or um, not just like rectangle that we can just times length times width, or a cubic or something, a cubic thing that we can just multiply length, width, and height to get the area. But in this type of function, it consists a lots of rectangles or a lots of polygons here, let's say. So what we're gonna do is take a part of it, small part of it, and that part is it's like the sample for all our space. So we can use here integration to solve for the area. So I'll just shade this. So this is called our d of x. Okay. So in other cases, we can see some functions using area looks like this. So what happens here? So when we can see here, so we're finding y is equal to fx. So when you put or indicate the height of the rectangle by x, so we'll have dy. And so next, have our formula. So dA is equals to y dx. So finding area in this type of function, we can see that the height is, or this is the height respects to y. So dA is y dx. So what happens here, it is put sideways or by x. So you can simply put here x dy. So that's it. So formula is a is equals, you can put our range here, b y dx, and a is equals to b a x dy. So that's it. Let's have an example here. So let's have an so divide here. So we cannot be, or we won't be to focus here. So okay, let's have our problem. Find the area under the curve y equals x plus 2, and the x axis is from x equals -1 to x. So um, so let's find our given first. So first you find the x and the y for the coordinate. So x equals 0, y equals 0, and we have here, so we have y is equals x plus 2, so we'll have y and x also here, so we'll have 2 and -2. So in that case, our coordinates here is, or for our range is 0, 2, -2, 0, or I mean for the curve. So let's plot it. So let's say this is 1, 2, 3, 4, 5, and 6. So another one, 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5, 6. Then we'll have here um, 0. So we can see we have -2 on the x here. So let's put -2 somewhere here. -2 and 1. So 1, 2, 3, 4, and 5. So okay, we have the plane. So let's plot. So the first is 0 and 0x and 2. So first point there. Second point is -2 on the x and 0 on the y. So right there. So let's continue. So just adjust. Wait, I think I got this a little bit wrong. So let's adjust it so we can draw, control the range more easier or more efficient for us. So sorry for that. Let's just put 1, 2, 3. So just put 2 here and 1, 3, 4, 5, and 6. So okay. So let's just put the +2 here, right there. So it will be easy to us to plot. So sorry for the little inconvenience, but let's start to plot the curve. So use the 2 and extend the lines. So here it is. So we can say that our range is x -1 to x +5. So what we're gonna do here is just take all the points and be mindful of your ranges. So I'll just see the 5 here. You just put that there. Give it a little bit extra. So we'll have there our curve. So the range is 5. So the area, the function where we're gonna find our area is ends with 5 and -1. So that is our shaded area. Let's not overshade it. So okay. So that is our shaded area. So let's find the area. So what we're gonna do here is let's plot. So let's take this part. That is our d of x. So let's do it. A equals. So where does it respect the dx? So it respects to y. So we'll use y d of x. So that is how we find our area. So um, we have to substitute. So what is our y? Y is x plus 2. So equals to x plus 2 dx. So let's add our limits. What is our limits? Negative 1 and 5. So that's it. So we're going to solve it this way. So we'll have a is equals to, so we're going to integrate it. So x plus 2. So the x is going to be the 2 and x plus 2 is algebraic function, so let's apply our rules. So x plus 1 here, so 2 over 2 plus 2 plus 1 constant, with is x, 2x d of x. Then we'll just put respect for our range, so 5 negative 1. So now I'll just put it in the middle of my camera. So let's replace units. So in here, it's what you're gonna do is replace with limits. Sorry for my penmanship. So is equals to this function is our basis. So we'll replace our range here respectively. So the higher range is minus by the lower range. So we'll have x squared will be 5 squared over 2 plus 2 times 5. So we close this minus. So first we did was 5. So 5 minus, so equals minus the lower range is negative 1. So negative 1 squared over 2 plus 2 times negative 1. So that's it. So if you want to make it easier for yourself, you can use a calculator or just manually solve if the equation is just an easy work. So we can use a calculator anytime we want. So 5 squared is equal to 25 over 2 plus 10. So we're gonna have is minus, so negative 1 half squared is equal to what? Is equal to negative 1/4. So if we have negative, or I'm sorry, negative 1 squared. Negative 1 squared is equal to negative 1 still. So it's still negative 1/2. So negative 1/2 here plus 2 times negative 1 is equals to negative 2. Okay, so we can just put simply so 1/2 should just so 2 is, so we just can transform it. So basic rules of integration, you can transform anything to much easier, or something much easier for you. So you'll have 25 over 10. So you'll just have going to plus so it will become 25 over 2 plus 10. It will just become positive 3 over 2. Just plus it. So that's plus. That's plus. So 25 plus 25 plus 3 is equals to 28 over 2 plus, it's gonna plus 10. So we arrived here. So 28 divide 2 is equals to 14. So 14 plus 10 is 24. So your answer is 24 square units. See this area. So that is our answer. So I'll get another bond paper here because we don't have space. We could use the back part, but so next. So another example. So find the area. Camera panning is wrong again. So you're bounded by y is equals 4 minus x squared in the first quadrant. So let's put our mind in or our attention to this part. First quadrant. First quadrant. So let's try to make our plane here. So let's have let's have 4x squared. So what can we do here? So first, so we can transform it. So let's make it x squared is equals to, what will happen? Y is put into another side, so negative y plus 4, or x squared is equals to negative y minus 4. So that's it. Reason being is standard form here is x minus h squared is equal to 4a y minus k. So let's find the range. So and see here is, excuse me, v v equals 0, 4 excuse me. So you can see that our parabola, this is a parabola, and excuse me, so so there is no, we have here h, but there is no h term. So when we have no h term, so the parabola, so no negative. So the parabola is opening negative or facing down. So y is equals to, let's make y is equals to 0. So let's equate. So 4 equals 4 minus x squared is equals to 0. Where did you get this? You get this from here. So you'll have, so let's put x on the other side. So x. Let's remove the squared. So what we'll have is square root of 4. Because we have 4, we don't have something to bring down. So let's just put square root of 4, and so it's equal to positive negative 2. But let's remember that in the problem, we are told that it is in the first quadrant. So we're gonna use positive 2. We're gonna use positive 2 because first quadrant is always positive and positive when it comes to x and y. So let's plot. So we have our range is from negative 2 and positive 2. So 1, 2, 1, 2. Negative 2, 2, 1, 1, negative 1. So, so y is, wait, let me see again. Did I miss something? I say, 4, 4. So y equals 4, so 4. So the parabola here starts here. I'll have 1 point there, 1 point here, 1 point here. So the parabola looks like this. So now it said that the area bounded by y is equals 4 minus x squared is in first quadrant. So let's just shade first quadrant. I'll just lightly shade it so it will not be much. So I have find the dx here. So let's take a part of it as dx. So this is our dx. So it is respecting y. So a is equals y dx. So let's substitute y. So what is our y? Again, y is 4 minus x squared. So equals 4 minus x squared. So we'll have 4 minus x squared. Don't forget dx. So you will have, I'll just divide our solution here. You'll have, put our, what? Should put our range. So our range is, so even if we have negative 2 here, but the problem asks for only just first quadrant. So first quadrant, so just we're gonna use range as 0. So range is 2 and 0. 4 minus x squared dx. So let's integrate. So equals, have here is a is equals to have, so applying same the same rules from our last lesson, we'll use, so just integrate this. So we'll have 4x because we'll add 1. So we'll have here over 1, but we'll just disregard it because anything divided by 1 or have a denominator by 1 is equal to itself. So let's have minus x. So 2 plus 1, when integrating basic integration, 2 plus 1 is equals to 3 over 3. So our range is to 0. So we'll have the function. So what we're gonna do here is substitute. Now let's substitute. So we'll have our a will be 4x for first 2. 4 times 2 minus minus what? So 4 minus 2 minus, so x3. So negative, or x should be 2 cubed over 3 minus, so this is our higher range and the lower range is, lower limit I mean is, and higher limit, so we'll have minus 4 times 0 minus 0 cubed over 3. So in this case we can disregard, so let's just disregard 0 here because 4 times 0 is equals to 0, and 0 negative 0 over 3 is just 0. So let's have 4 squared would become 8 minus 2 cubed is equals to 8 over 3 over is 3. So 2 times 4. 4 times equals to 3. So we'll have here, so times 8 over 3. Okay, there must be something wrong here. 2 cubed. We'll have 8. We'll have 8. So we'll have an indefinite here. So 8 over 3. I have no answer here. It's 2.66. So I'll just put this way, I think. So thirds BH. Wait, did I miss something here? 2 minus 3. 24 minutes. 6. 4 times 2. 8 minus 3. So I'll just put this as is. So 8 over 3, you'll just convert this to 8 over 3 negative 8 over 3 is equals negative 2.66. Just 8 negative 2.6666. So 8 minus 2.6666 equals 5.33. 5, 3, 3, 4 square units. So okay, another example. So can I use the back part? No, I can't. I'll have another bond paper. So okay, find the area enclosed. So we have another one here. Example by 1 petal. So we are I'm dealing with polar functions here, so of the curve. So the problem I'm gonna use, this is very common when it comes to polar functions, and this is very familiar for some. So polar curve. So polar curve has symmetry. So let's see. So the problem will give the function here. So here we'll have 1, 2, 1, 2. So the curve goes as this. So here also. So it has symmetry. So let's just find the area here. So it's just 2. So what we're gonna do here, so say this is equated as this. So we'll have one. Let's just focus on 1 petal here. So if it will be continuous, it will become pi over x. So here, because it is symmetrical, it will be negative pi over 6. So radius is 2 cosine 3 theta, and A is equals root of and 1/2 r squared d theta. So let's solve the area. So area is square root of 6 and negative 6. So this is our range because it has symmetry. So sorry if it's not have seen that, but it has symmetry, and that is our range. So higher, I mean upper limit, lower limit. So let's use this 1/2 and r. What is our r? 2 cosine 3 theta squared d of theta. So is equals to, let's just, so 1/2 is times 2 is equals to, oh I mean um distribute here, so 2 pi over 6 pi negative pi over 6. So we'll have cosine squared and theta d theta. So a equals 2, arrange 6 pi 6 negative, don't forget 1/2 1 plus cosine 6 theta d of theta. So equals 6 negative pi over 6. So 1 plus cosine 6 theta d of theta. Okay, so a equals, we're gonna have here is theta plus sine 6 theta over 6, and that is our function this time. So just substitute theta. So we'll have the range pi over 6 negative pi over 6. So is equal to pi over 6 plus 0 minus negative pi over 6 plus 0. Oh, I mean theta. Okay. Oh, it's really 0, but sorry. So what we substituted here is our range to this function. So we'll have positive pi over 6 and negative pi over 6. So we can equate that into this, disregard this. So pi over 6 plus pi. So why did it become positive? So we have minus here and the negative sign. So minus will be positive. So pi over 6. So equals 2 pi over 6. So we'll have here, we can still simplify this. So we'll have, so cancel, divide 2 is 1 pi, just pi, over 3. Area of petal. So this part is pi over 3. The area is pi over 3. So if we ask, what is the other areas of the petals? So we know that when it comes to polar functions, you have symmetry. So when you have symmetry, you have 3 petals. So let's just, to get all petals, so value all petals, so all petals is equal to pi over 3 times 3. So what is the answer? Pi over 3. So is equals to just pi. Cancel the denominator. So the area overall is pi. Okay. Next, have another lesson. So we one the first lesson we used integration. Um, we used integration to find the volume. Now we have volume using integration. So there are three methods. First is disk method, shell method, and the last one is washer method. So what we're gonna do here? So disk is it's just I just use a broken T square here. Another one here. So usually disk method looks like this. You'll have your function here, and you'll have the range here. So A and B. So you have here dx. So what we're gonna do? So let's say this is our area of rotation. Area of rotation pertains that um, you'll find the dx or all the function that corresponds to a disk that rotates through the area of rotation, which is our x-axis. So if a disk rotates to an x-axis, meaning the height is our radius. So this is your height. It's h, not a. So it's height. Let's clear this thing a little bit. So that's it. H. Yeah. Right. So you'll draw an imaginary disk here. So be careful and be symmetrical. So the disk looks like this. So it rotates right there. So it looks like a disk to you now. So volume is equals to pi r squared h because it is a cylinder. So V is equals V over A range times pi r squared function of x dx. So next, shell method. Let's say A and B here. So shell method looks like this. Looks like a shell. So this is our dx and this is our y. So let's say the area of rotation is here. Rotation. So this shell rotates from the y-axis. So this is your radius r. So and that is our y and this is our height. Okay. So the formula is v is equals 2 pi um, limits here. So r of x h times x dx. So this is on should be based on x-axis. So if like this, it rotates through y-axis. You'll just I'm sorry. I mean, if it rotates through y-axis, you have x. So and if this function, for example, you have another function here, and the shell goes like this, but you'll find it here, your dx. You'll use r 2 pi your B and A, your upper and lower limits. So R, Y, H, Y, dx. Okay, so washer method. So usually when you have washer method, sometimes looks like this. So this is the y is equals to g of x. And this one is y is equals to f of x. So example like this. That is our function. And we'll have here our dx. Our dx. Our dx. So what does a washer look like? So a washer is something that where the bolt and nut. So we see the bolt and nut in things. So washer is something that um, clamps things together, or something that looks like this. That. So washer looks like that. So let's draw a washer here. So, uh, so the thickness is our dx, and this is our washer. So okay, so A, so area of a washer is pi f of x squared minus pi times. So I should close this. So pi times, what do you multiply by pi? G of x squared. So when it comes to volume, we find limits or upper lower limit pi fx squared minus g of x squared dx. Okay, so that is our formula for the three: the disk method, shell method, and the washer method. Okay, so let's have examples. So disk method. Disk method first. So let's have a problem that goes like this. Okay. So we'll have a parabola from 0. I'm sorry for my drawing skills. I'm not a drawing, or I mean I'm not good at drawing. I'm just good at painting. So the range is from here to here, right there. So this is our shaded part. That's our shaded part, or like a hairy part. Lol. So let's have our dx here. Dx, or I mean dy, because it's respecting dy. Y. So let's draw the disk. So the disk looks like this. So where is our axis of rotation? Axis of rotation was here on x-axis. So the disk looks like this. So the thickness of the disk is our dy. So dy is here. So it's 1, 2, 3. So y equals to x cubed. So let's draw the disk here. So I just move my things here. So if you can see, this is our x-axis, and the disk is skewered like that. This is our area of rotation, which is the x-axis. A, area of rotation. So A equals pi r squared. So a is equals to pi. R is the x cubed. So x cubed squared. So b is equals a times bx is equals to pi x or dx. So okay, let's solve. Let's do limits. This is 1, this is 3. So sorry, I mean 0 from 0 is 1. So we have 0 and 3 pi x to the fourth dx. So let's integrate, substitute back our function. So pi, just put pi outside. So our limit is 3, 0. Um, okay. So x or dx. So in this case, we can integrate. So what we'll have here is, if you integrate, basic integration. So pi times x, 4 plus 1 is 5 over 5. So with respect to r, lower, and so we have 2 minus. So basic integration. Substitute. So pi times, so pi times 3 to the fifth power over 5 minus 0, 5 over 5. 5. So let's just disregard this 0, because 0, 0 in any power, even 1 million pa ina, is just 0 again. So let's just disregard. So pi times 3 to the fifth power over 5. So what we're gonna do is, calculate 3, 5. So 2, 4, 3. So your answer is pi 243 over 5. So you can still simplify this. Let's say 245 divide 3. So 245, 243, I mean divide 243 divide 5. So you'll have 48.6. 48.6 pi is the cubic units volume of the disk. Okay, next. Here's my bigger ruler. So you can see here 48.6 pi cubic units. Next, example for shell method. So shell method. So however is, we have given the we have given the problem, the height is y is equals root of x, range is equals to y equals 0, and x equals 3. So our AOR, or area of rotation, is on y-axis. So what we're gonna do here, so let's create first the plane. So y is 0, 2, 3. So square root of x. So we have and this is our r, or radius. Here, let's have d of y. So this is our height. So this is our x. So let's solve. V is equals to pi um, dA. So the formula is this: r of x times h of x. Why we use dx? So because it is standing on dy. Okay, so v equals 2 pi for, I mean, 3. Just have the range of 3. 3 and 0. Tapos, r of x is x, square root of x dx. So, if we want to simplify this to have a much easier, so we can just make this 2 pi, so 3, 0. We can like um, derive x here. So x should be x 1/2, and square root of x is just x 1. Okay, so dx still the same. Just I'll just made it or transform it in another degree, which is easier to deal with. So we'll have b equals, so right now we can add this too, so we have much more easier function. So 2 pi, so our limit, which is 3 and 0. So we have the denominator of 2, so it could be basic integration plus 1 1/2. So 2 over 2, 1 plus 2 is 3, 3, and other is 2, same denominator, so dx. So 2 pi x 3 3 on the power of 3 halves dx. Okay, so we can integrate. So v, volume, let's solve for the volume. V is equals to 2 pi x 2 pi x 3 over 2, 3 over 2 over, so this is 3, so we're gonna integrate. So 3 plus, so 3 over 2 plus 1, so 2 over 2 over 3 halves plus 2 over 2, so 4 0. You'll have what? 2 pi times x 5 over 2 over 5 over 2. So what we're gonna do here, so this is such a very hard thing to integrate. So what we're gonna do, so I'll do is 2 pi, I'll just put this 5 over 2 outside, so we'll just have x 5 over 2 times reciprocal over 5 for 0. So we have 2 pi, 2 pi, well, we have 2 pi, this pi, not a Japanese structure or Japanese arch. So 2, or x, I mean, is so this is function, right? Okay, so let's have 2 times over 5th, so 4, or 3 rather, 5 over 5 minus 0, 5 over 2, 5. So we'll have 0, so this is disregard, so I have 2 pi. So you can use your calculator. So 2 times 3 is 5 over 2. So this is what I input in my calculator. So 2 so equal so you can input now or just 3 pi over 2. So 3 pi over 2. Answer is should be around 32. So 2 times 32 over 5. So times 32 is 2 pi. I'm sorry, my handwriting is bad. So 64 over 5 equals to 2 times 64 is 128. 128, just add pi over 5. You can put your answer as is, but if you want to really make yourself uncomfortable, just 128 divide 5. So we have 25.6 pi. Also our answer. So alright, last one. Disk, washer method. So washer method. Washer method. So washer method is we have the problem is we have given the range is 0 0 3 0. So have y. So v equals um I mean pi times g of x and f of x minus f of x of x. So sorry for my handwriting, that's minus f of x dx. So going to is y is equals to g of x equals x. So y equals f of x is equals square root of x. So let's draw the function plane. So let's have here, it's a bit longer. I'm sorry. Yeah. So we have, what is the range? 0 0. Let's make point here. 1 3 4 5. Let's make it 5. 0. So the first point was here, 0 0. So 3, x is 3 0. So we'll have here, this is the range. So but the function is square root of x and x. So you'll have, looks like this. Cross, whoop, should be straight with a 3. So just assume that this point and this point is straight. So so let's have our d of x here. D of y, I mean, because our range is from 3, say up, it's straight, yeah, straight. This the x. So the problem states that this is g of x is equals to x, and this, oops, yan. So the problem states that g of x is x and f of x is square root of x. So the axis of rotation is from x. So AOR is on x axis. Okay. So v is equals 3, 0. So this is our limit here. So pi x, or we have g of x minus f of x squared dx. There's no squared. I'm sorry. We'll use this. So let's substitute. V is equals 3, 0, pi x minus x squared dx. So equals to pi 3, 0 x equals, sorry. So substitute or integrate, I mean. So x squared over 2 minus x cubed over 3. So we should have terminated this, but let's just put there. So given substituting 0 will results to 0, so let's just leave this lower limit. Let's just leave the pi x should be 3 squared over 2 minus x. So x is, I'm sorry, this should be 3. That would be 3 over 3 cubed. So we'll have here, so input 3 squared over 2 minus 3 cube over 3 equals to just 3. Wait, 6 minus 2 times 3 is 9 times 27 divided. So have pi 1/2 is equals to pi squared. Alright. So that is our final lesson. So that is my lesson for today, and I'm Danner Doy Tumalay from DS Packaging Engineering, and thank you.